Hello dear technology enthusiasts and creatives. Welcome to this video in which we will learn about the servo motor and how to control this motor with an Arduino board. This amazing motor allows you to create robotic projects like the ones you see on the screen. The servo motor is specifically designed to provide precise control of angular or linear positions. Unlike regular motors that rotate continuously, servo motors are controlled by a pulse width modulated (PWM) signal, which determines the motor's movement angle and position. As you can see, here on the left is the servo motor, and here I have disassembled it to show its internal structure. The servo motor consists of a DC motor, which is the main component of the servo system, capable of operating at high speeds while providing moderate torque. The gearbox connected to the motor adjusts the motor's high speed to a lower speed while significantly increasing torque. This adjustment is extremely important for motor applications that require highly precise and controlled movements. I measure this variable resistance at the output shaft position. This shaft detects the voltage generated by the shaft's rotation. This feedback is necessary to ensure accurate positioning of the servo. The control circuit acts as the central hub for the servo motor, taking the desired position as input and adjusting the motor output by modulating the power based on feedback from the variable resistance. I'll explain this more here. As you can see, servo motors operate on the principle of negative feedback, where the control circuit adjusts the motor movement to match the input command given by the user. The target position means the desired angle, and the variable resistance measures the current angle. Then, the positions are compared, and the resulting error is fed to the controller, which in turn controls the motor, thus constantly trying to reduce the error until the target position matches the current position. This is called negative feedback. Pulse width modulation, PWM, is the signal given to the servo motor. In addition to the positive and negative poles to power the motor, there is another input that receives a control signal. The control signal is a pulse width modulated signal where the width varies from 1 to 2 milliseconds. This means the rotation angle is determined by the width of the pulse. When the wave is given, for example, when the pulse width is 1 millisecond, the servo motor position is 0, while at 1.5 millisecond the motor position is 90 degrees. When the pulse width is 2 milliseconds, the servo motor position is 180 degrees. Through this width, we can control the rotation angle. Now, we will conduct an experiment called sweep, where the servo motor will move left and right in a continuous loop. We will connect the Arduino board to the power supply. I want to mention here that the Arduino board will remain connected to the computer, thus it will be powered through the USB port. After I finished connecting the servo motor to the control board, I will now program it. In the Arduino IDE, there are examples for controlling the servo motor. We have this example. I will open this example, and this library has been used. Here, this object a myservo and this variable a POS have been defined. In the setup function, pin number 9 for the Arduino has been defined as the pin connected to the servo motor. Then, in the loop function, which is repeated continuously, we increase 1 every time to the variable's POS, and give the command to translate this variable as an angle. The motor needs time to translate it, so we will wait for 15 milliseconds, then we will repeat the command again. This time, we will start at 180 and decrease 1 each time from the variable APOS. After finishing that, the program will restart from line 21 and continue until we turn off the device. I will upload this program to the board. After we finish the previous project, we will now do this practical project called knob, where we will control the position of the servo motor using a potentiometer. We will read the voltage across the potentiometer, and based on the reading, we will change the rotation angle of the servo motor. After I finished once again connecting the control board to the servo motor and adding the examples available on the Arduino IDE, then the servo. In this program as well, Using the servo library, then this object, a myServo, and these two variables were defined. Pot pin A is the variable that reads the voltage on the potentiometer, then this variable. In the setup function, pin number 9 was again defined to be the one connected to the servo motor. In the loop function, which is continuously repeated, we read the value on pot pin A, then we make this map A to scale the read values proportionally so that 0 represents 0 and 1023 represents 180. Then we will give this value as a command to the motor and wait to translate it into actual movement. I will upload the program. As you can see, by changing the potentiometer, the position of the motor changes. As you saw in the previous examples, controlling the servo motor from the Arduino is very easy. But when we use multiple motors, we must use a dedicated board. For example, with this board you can control 16 servo motors with just 2 wires connected to the Arduino, thus saving the number of inputs and outputs that can be used for other sensors. Connecting this board to the Arduino is very easy. We connect the SCL pin and the SDA pin, then the VCC and ground. Then we connect the motors to these pins. For example, we will do this experiment. We will need 2 potentiometers and 2 servo motors. Then we will connect the power to an external power source and connect the SDA and SCL to control the board. After I connected the 2 servo motors to the PCA 9685 servo control board and also connected the board to the control board, the 2 potentiometers were also connected to the control board so that the voltage value on them is read and this voltage is translated into the angle of the servo motor. I will now program the board. The program is as follows. We will use these 2 libraries, then define the frequency and define the A0 and A1 pins as inputs through which the potentiometer value is read or the voltage on the potentiometer is read. This is done through these 2 functions. This value is read and translated into a pulse width or wave width that is sent to the servo motor. 0 corresponds to 150 microseconds and 1023 corresponds to 600 microseconds. Then here the command is given to the servo motor to move to the desired value and wait for 20 milliseconds to translate that. I will now rotate and adjust the potentiometer and we will see the translation of that on the servo motor. Likewise, for the other motor. And so we come to the end of today's video. I hope you enjoyed and benefited from it. Don't forget to like the video and subscribe to the channel to stay in constant touch with all new content. Share your ideas and inquiries in the comments. Until next time, stay creative and explorative.